Hello friends, I am Vishan Singh Chaudhary, a master student of NIT Warangal. In this video, we will see how to find a solution of system of linear equations. You can expect at least one question either in IIT JEE or in IIT Advanced from this topic. Okay, so let's begin. We will begin with the solution of system of linear equations in two variables. After that, in three variables if time permit. So consider a pair of linear equations in two variables, that is a1x plus b1y equal to c1 and a2x plus b2y equal to c2. Now we want to find out the solution for this system of linear equations. It means we want to find out the value of x and y which satisfy both the equations simultaneously. As we know that a linear equations in two variables represent a straight line. So call it as a line L1 and this as a line L2. Now we have a two straight line. Suppose these are the lines. They may intersect each other, they may parallel to each other, they may coincide each other. So now we will take a first case when the lines are intersecting each other. Intersect each other. Suppose this is a line L1 and this is a line L2. These lines are intersecting at a point A, that is A equal to x comma y. This A is lie on L1 as well as on L2. It means this point will satisfy line L1 and L2. So from this we can say that the value of x or y of this point will satisfy both the lines L1 and L2 simultaneously. So when lines are intersecting, we are getting a single point which satisfies both the lines. So this is a unique point. So we conclude that unique solution exists in this case. Okay, now we will come to a second case when the lines are parallel to each other. Second case, parallel to each other. Okay, suppose this is a line L1 and this is a line L2. Now we have two lines L1 and L2. Suppose we extend it in right hand direction, both the lines, or if we extend this in left hand direction, we can see that both the lines never meet each other in any direction if we extend. So we are unable to find a point where both the lines intersect. So we are unable to find a value of x and y which satisfy both the lines. So from this we can conclude that no solution exists because we are unable to find a point which satisfy both the equations. Okay. Now we get a third case. What is the third case? When the lines coinciding each other. Third case, coinciding each other. Suppose this is a line L1 and this is the line L2. Okay, if we take a point here, this point will satisfy both the lines. If we take a point here, this will also satisfy both the lines. If we take a point here, this will also satisfy both the lines. So here we can see that we are getting infinitely many points which satisfying both the lines L1 and L2 simultaneously. It means we are getting infinitely many values of x and y which satisfy both the lines L1 and L2 simultaneously. So from this we can conclude that when the lines are coinciding each other, we are getting infinite solution. Infinite solution. So here when the lines are intersecting, parallel or coinciding, we are getting three types of solution. First one is no solution when lines are intersecting. Second one is unique solution when lines are intersecting. Second one is no solution when the lines are parallel, and third one is infinite solution when the lines are coinciding each other. So under what condition we can say that the solution is unique, no solution or an infinite solution? Let's see. Now we want to check whether the solution is unique or no solution or an infinite solution by using the values of a1, a2, b1, b2 and c1, c2. So we will take a first case, that is unique solution. Unique solution. If the value of a1 upon a2 is not equal to b1 upon b2, then we can say that a unique solution exists. And as you also remember that a1 upon a2 is not equal to b1 upon b2 is a condition of intersecting of lines. So now in second case, that is no solution. If the value of a1 upon a2 is equal to b1 upon b2 but not equal to c1 upon c2, in that case we can say that the no solution exists. And we know that this condition is a condition of parallel lines. This is a condition of a parallel lines. And third, that is infinite solution. Infinite solution a1 upon a2 is equal to b1 upon b2. See, in this case a1 upon a2 is not equal to b1 upon b2. In this case a1 upon a2 is equal to b1 upon b2. In this case a1 upon a2 is equal to b1 upon b2, but equal to c1 upon c2. So if the value of a1 upon a2 is equal to b1 upon b2 is equal to c1 upon c2, then we get an infinite solution. Okay, so this is the hard and fast rule to check whether the solution is unique, infinite or no solution. Now, if we extend this system of linear equations in 3 variables or 4 variables, then this rule is very complicated. So for removing that complications, we introduce a new rule that is known as a CRAMER rule. While that tell us about the uniqueness, no solution or infinite solution of a system of linear equation, as well as it will tell the value of x or y to satisfy the linear equations. That is CRAMER rule. In CRAMER rule, we represent a system of linear equation in the matrix form. Suppose matrix A, that is the matrix of coefficient of x and y, that is a1, a2, b1, b2. That second one matrix is B, that is x and y, and third one is C, that is a right hand side vector c1, c2. Now we will calculate a determinant by which we can tell that the solution is unique, no solution or infinite solution. That is determinant D. D is the determinant of the coefficient matrix, that is a1, a2, b1, b2. Now we will take another determinant, that is d1. In d1 we will replace this column by this C column, that is c1, c2, b1, b2. Now another, that is d2. In d2 we will replace this column by this column. Okay, so that is a1, a2, c1 and c2. Now you can see that we have three determinants, d, d1 and d2. In d1 is the determinant of a coefficient matrix. So D is the determinant of a coefficient matrix. In D1 we replace a left hand side vector with this C vector, and in D2 we replace left hand side vector of D with C vector. Okay. Now from these values, how we can say that the solution is unique, infinite or no solution? Let's see. First case, when solution is unique. Suppose the value of this D is not equal to 0. The value of D is not equal to 0. In that case, definitely we will get a unique solution, and the value of x will be equal to d1 upon d, and the value of y will equal to d2 upon d. Okay. So when d not equal to 0, we will get a unique solution. Value of x equal to d1 upon d, and value of y equal to d2 upon d. So now second case, for no solution. In no solution, the value of d should be equal to 0, or either d1 or d2. Either d1 or d2 is not equal to 0, then we can say that the solution is no solution. Now third case, that is infinite solution. In infinite solution, the value of d is equal to 0. D is equal to 0. D equal to 0 and the value of d1 equal to 0 and as well as the value of d2 should equal to 0. If the value of d1 and d2, all the three values will equal to 0, then we will get an infinite solution. In that case, we will take a value of y in terms of x from L1, then we will put that value in L2, then we will get a value of x and value of y in a term of x. If we put a different values of x, we will get a different values of y. So in that case, in that manner, we will get a different value, infinite many values of x and y will satisfy both the equations L1 and L2. So we have three cases: unique solution, no solution, and infinite solution. In unique solution, d is not equal to 0 and x1 equal to d1 upon d and y equal to d2 upon d. And no solution, d equal to 0 and either d1 or d2 is not equal to 0, then we will get no solution. For infinite solution, d should equal to 0 and d1 be equal to 0 and d2 should be equal to 0. Means all the three determinants should equal to 0 when the solution is infinite solution. Now we will see an example on this CRAMER rule. This example may be earlier asked in IIT or in IIT Advanced. I don't remember that, but yeah, surely that was a competitive question. So the question says like that: we have a system of linear equation like k plus 1 into x plus 8y equal to 4k. This is our first equation, and second equation is kx plus k plus 3y equal to 3k minus 1. So now, for what value of k, the solution of this system of linear equation is no solution. We want to find out the value of k for which the solution should be no solution. As from CRAMER rule, we know that the determinant of this coefficient matrix should be equal to 0. So first we will take that k plus 1, 8, k and k plus 3. Determinant of this should be equal to 0. Now we will multiply k1 into k plus 1 into k plus 3, k plus 1 into k plus 3 minus 8k should equal to 0. Now further simplify, this is k square minus 4k plus 3 equal to 0. From this we can get k minus 1 into k minus 3 should equal to 0, and this is equal to k equal to 1 and 3. From here we are getting k equal to 1 and k equal to 3. So for both the values the solution is unique, so solution is no solution. Let's see. Let us put a value k equal to 1 in this equation, then we will get k plus 1. 1 plus 1 equal to 2x plus 8y equal to 4, and second k equal to 1 putting it, then you will get x plus 4y equal to 2. So now we want to find out whether this system of linear equation is having a no solution or not. So first we will calculate d equal to 2, 8, 1, 4. Now multiply 2 into 4, that is 8. 8 minus 8 equal to 0. d1 we will replace this column by 4 2. That means 4 into 2, 8 into 4. That means 4 into 4, 16. 8 into 2, 16. 16 minus 16 is 0. And d2 we will replace 8 and 4 by this 4 and 2. 2, 1, 8 and 4. 4 into 2 is 8. 8 into 1 is 8. So 8 minus 8 is 0. So here you can see that the value of d, d1 and d2, all the three values is 0. So this is an infinite solution case. Infinite solution. But what we want? We want no solution. So k equal to 1 is not valid. Now we will check whether k equal to 3 is valid or not. So k equal to 3, we will put k equal to 3 in this equation. We will get 4x plus 8y equal to 12, and k equal to 3 in this equation. We will get 3x plus 6y equal to 8. So now we will calculate d, that is d equal to 4, 3, 8, 6. 4 into 6, that is 24. 8 into 3, that is 24. 24 minus 24, that is 0. Now d1 is, we will replace 4 3 by 8, 12 8, 12 8, 8 into 6. 12 into 6 is 72 and 8 into 8 is 64. So this is not equal to 0. Why? 72 minus 64 is 8. Now d2 is, we will replace 8 and 6 by 12 and 8, 4, 3, 12 and 8. So 4 into 8 is 32 and 3 into 12 is 36. So 32 minus 36 is minus 4, that is not equal to 0. So here we are getting d equal to 0, but d1 or d2 is not equal to 0. So in this case we are getting no solution. So when k equal to 3, we are getting no solution. So our answer is k equal to, when k equal to 3. When k equal to 3, for this system of linear equation, you will get no solution.